Dear all, I am your TA Balaji and today we will be discussing the solutions for assignment 9. Question 1. What is the delay of the critical path of the circuit shown in figure 1? So as indicated in red, this critical path of the circuit traverses through I1, I2, N3 and N4, which is by the way the answer for question 2, and it has a delay of 1 plus 1 plus 4 plus 2, which is 8. That's all. Question 3 and 4. What is the delay of the critical path of the circuit shown in figure 2? So in this figure again, the critical path is as shown in red, which is I1, I2, N2 and N4, which is the answer for question 4, and it has a delay of 1 plus 1 plus 4 plus 2, which is 8, right? What is the propagation delay of a 128-bit ripple adder given the delay of a carry and some are 2 and 3 units respectively? So again, if you have a ripple carry adder, you have 127 times, you have like 127 times t carry plus t sum. Right? It's like this. So hence the answer will be 257. So question 5, the answer will be 257. Question 6. Which of the following inputs is timing critical in the last full adder in a 16-bit ripple carry adder? So in a ripple carrier adder, always the Cin will be the most critical input. So if you look at it in the last adder, right, the Cin will be the last arriving thing, which will be the most critical input to it. Right. Question 7. A 512-bit carry skip adder is implemented using blocks of 4, 8, 16 and 32. TGP, T bypass, T carry and T sum are given. The critical path delays of A, B, C and D are. So this is a straightforward substitution of the formula, which is basically this as indicated. You will obtain this formula. You will obtain the answer when you substitute this formula. That is here's a simple Python script that can execute the formula for these 4 different values of M, and for each of these values you get the result, right? Yes, so that's question number 7, right? Question number 8. From question 7, what can you infer as the optimal number of blocks with the least path delay for 512-bit carry skip adder? Yes, so the value of M is equal to 16 is the least delay, which is 194, but the number of blocks is 512 divided by 16, that is 32, right? So that is 32. And question number 9, 512 bits carry select adder is implemented using 4, 8, 16 and 32 with TGP, Tmux, T carry and T sum is given. Find out the delays, right? So again, question number 9 can be evaluated with this formula here, and with a simple substitution of the formula for each of these values, you will get the result as shown here. Yeah, so here we are asking for 4, 8, 16 and 32, right? So we are asking for 4, 8, 16 and 32. So hence the answer is this, right? Which is, you should look at the answer from here, 4, 8, 16 and 32. This is the answer. Okay. So finally question number 10. Question number 10 involves, it's asking you when 1, 1, 1, 2, 3, 4, 4, 1, 2, 3, 0 and 2, 3, 4, 5, 6 and this, right? So when you add these two up, the carry of this will go and sit on this, carry of this here again, here again, here again, here again, here again, and finally it will propagate there. So it is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 and 7, right? So given that carry bit is 1 unit and you have like basically 7 times 1, which is as shown over here, which is 7, right? So question 11 and 12. So for question 11, you've been given a configuration of A and B, and Ci is flipped from 0 to 1. So let me follow the color code here. The values in question 11 can be observed if you follow the color code of red, and I've written down each of the values for A, B, and so on here, and you'll observe that C0 is remaining as 0, whereas C0 bar remains as 0, and S bar switches from 1 to 0 as shown over here, right? Yes. So with that knowledge, you will be able to, if you observe the working for different A, B, C, I, you will be able to conclude that S bar crosses VDD by 2 before C bar does. Since C bar is always 0, C bar does not cross VDD by 2 in response to change in input. These are 2 correct answers. Similarly, question number 12 can be, so the working for question number 12 is all indicated in the color black. So if you go back and observe the different workings for question number 12 as shown in color black, right? So all of this, you can notice that the output C0 bar is 1, whereas S bar switches from 0 to 1. Hence you can mark that S bar crosses VD by 2 before C bar does. C bar does not cross VD by 2 in response to the change in input. So I'll just leave you at this so that you can observe the working for question number 11 and 12. Yeah. So if you guys have any questions regarding the solution, please do write on the discussion forum. Thank you.